So, welcome to this re-recording of the first part of the second lecture on networking in HTTP. So, as I just announced on Canvas, I paused my recording and I only realized that I had done that after half an hour roughly. So, I'll go through the first part of the lecture again here and upload it later on. It's mainly an introduction, so it's actually not that relevant for the course content, but of course for completeness it should be there. So first of all, I've gone through the survey that half of you have filled in and have looked a little bit at the prerequisites, at the skills and expectations you all have. And interestingly, I would say about half or maybe more are on this level here. They say you mostly have basic skills, no skills, a different background, and so on. And then you have a bunch of people in the middle that basically have some knowledge in HTML, CSS, PHP is quite common, but some minor or sometimes outdated knowledge on the basic web technologies. And finally, of course, there are some people that are extremely experienced and might have more knowledge than I have. So important for you is whenever you question yourself, why are we doing this in class, or is it going too quick? Please think about the different prerequisites that you all have in class. Then the recording, and that's of course fitting now that I re-record something here. There is a discussion right now on Piazza a little bit on recording or not and so on. The important thing is that content will be available as videos. So don't worry about that. And I am aware of the people at HMV, the industrial people, and the people in Akureyri. I know you exist and I know you need the material, so please don't worry about getting the recordings. The thing is, how I do these recordings might change, and I will decide on that this week. So if I can't use my own computer in lectures and record that, then I will not record the entire lectures, but instead I will pre-record the lectures in smaller parts. And that means basically that I take the different things we have to discuss and record them, but it will be shorter videos, like 10 to 20 minutes, and they will be on different topics instead of doing it in class. And actually that's more work for me, but there is enough research that shows that that's better for learning. It's more successful because more people watch it, and it's actually also encouraged here at Reykjavik University. So if I don't record the whole lectures, don't worry about it, you will still get the relevant information. Finally, because we had one case on Piazza, please don't post any public questions that have solution hints in them. So now for the very basic first assignment, if you ask me, should we use this or that tag, that's already a hint on how to solve things. And especially if I answer that, if I say yes, then I have given you the solution. If I say no, then I've told you that it's wrong. So it's please don't post that, because we're basically telling other people what to do. And send me those things in private. If I think it's a good question, and if it's not very, if it doesn't give any hint, then I can still pose it as a public question with an answer. So be a bit careful about it, especially if you know a lot. Think about, okay, what could actually, if someone doesn't know HTML, am I posting a solution here or not? So this lecture covers networking basics, and it covers HTTP. And actually in class, I did not get to the last 3 points. So the methods, the method properties, and the cookies will be covered in the beginning of lecture 3 in the HTML lecture. For the lab this week, this also means you don't yet have any HTML knowledge. So it's mainly about setting up the tools, understanding the assignment, and so on. The learning outcomes for this course, the first 3 are from the syllabus, the other 3 are not as important, but they are added for this lecture. You should basically know HTTP, meaning you should summarize what HTTP requests and responses are, list the different verbs or methods, explain their purpose, and explain what kind of features they have, what kind of required content they have, and so on. And then on a larger level, you should be able to distinguish between what's the internet and what's the World Wide Web. Explain IP version 4 into the level of detail we go here, and summarize a little bit the purpose of TCP and IP, not in too much detail, since those things are complicated and we only have a very short time to cover them. And the literature is also in the module description. So if you go into Canvas and you go into the modules, you can see that in each lecture you have the literature and also you have the slides, which I try to add before each lecture. And in this case, I also add the YouTube video here, so you'll probably find it anyway. Good. This slide I showed in the first lecture, and it's all about the World Wide Web, that it's invented in 1989 and so on. But the question is, of course, what's the difference between the World Wide Web and the internet? And of course, we often use those interchangeably nowadays. Typically, we use internet because it's quicker, but what's the difference? And Tim himself put it like this. He said the internet is a network of networks. It's basically computers and cables, so hardware, physical things. The web is abstract, it's more an imaginary thing. Information space, so it's computers in the internet. In the web, it's documents, videos, sounds, images, and so on. And a bit more specific, the Wikipedia definition for internet reads like this. The internet is the global system of interconnected computer networks that use the Internet Protocol Suite TCP/IP to link devices. So it's really about how to connect computers. And before the internet, we had something that was called the ARPANET. That was the predecessor of the internet, which was actually founded by the Department of Defense. So it's originally a military thing, an academic thing, how to get information quickly from point A to B. But even back then, they used the TCP/IP protocol suite, which is still in use today. So that hasn't changed so much. And of course, those things here on the right in the picture, you see that's one of those computers that they used as a gateway, as a node, basically. And back then, you could draw a map of that. So here in 73, I think 68 was when the ARPANET started. In 73, you could still draw this small map that said, okay, we have one computer at MIT, or actually 4 computers. We have one machine somewhere at University of California, Los Angeles, one at Stanford, and so on. And you all know that it has evolved pretty rapidly. So today, if you look at, for example, Iceland ranks 2nd in the world. 98% here have internet access of the population. Only the Falkland Islands are actually higher. But then this decreases rapidly. So you see it's still a little bit here in the UK, it's already 94%. In a lot of European countries, it's much lower, especially elderly population or population in rural areas often doesn't have internet. And that's something to keep in mind. And this is why I have the second one here. If you look at the actual regions, the different continents or parts of the world, you see that 2017, even in Europe, we only had 80%. So only 80% of the population are connected. That means you have 20% left that can't access anything on the internet in an easy way. So they have to ask someone or so on. And this, I again like to connect to the first lecture. This, of course, means you have some kind of responsibility. Are you designing a service that has to be used by the entire population? Then keep in mind that there are 20% that can't. Interesting if here in this chart is also the growth. So if you look at Africa in 12 years here, it has grown from 20 to 21, from 2 to 21.8%. So a tenfold increase basically. And this means if you want to make business, this is, for example, an area that's extremely interesting because it's developing so rapidly. And one of the main, this is of course not visible here, but one of the main reasons why this has happened is basically mobile phones. Because suddenly you don't anymore need a copper cable to connect to the internet, but it's enough to have a phone. And this enables this giant leap in Africa. And you can expect that this will rapidly go up to, close up to the other numbers basically in the coming years. I didn't find any up-to-date numbers, but already in 2018 I would expect this number to be much, much higher. So keep that in mind. Also keep in mind, not everywhere in the world do you have internet as quick as in Iceland or in industry first world countries. Especially if you think Africa, you have mobile connections, you have maybe bad coverage. So if you design an application, keep in mind, should it be usable in remote areas, then don't put super heavy content in there, big pictures and so on, that take a lot of network traffic. And this is the last slide where I realized that I had to pause the recording. So the question is now, how does the internet work? We know that it's a network of networks, it's computers that are connected, but what actually is the working horse under the internet is TCP/IP. So that's this protocol suite that makes sure that essentially your data reaches point B from point A. And this includes addressing. So similar to when you send a letter, you have to have some kind of way of identifying a single computer. I would like to send something to Google. I would like to send something to Grisha at Reykjavik University. And you have to have a way of how to send that data and make sure that it finds the right way. So it's not enough to have an address, you also have to know how to get to that address. So this is done by TCP/IP. Then you have something that's called segmentation. Typically, only small portions of your data are sent at a time. So if you would like to view a video, for instance, you don't send the entire video, but you cut it into packets, you segment it, meaning at the end you have to put it back together. So this is what TCP/IP does. Then it offers a simple interface. So if you would like to write an application, you don't have to know all the details of these protocols, but you have a simple, for example, you have a send function, and that one takes care of all the nitty-gritty details here, like the addressing, like the segmentation, and so on. Finally, reliability. Things go wrong. For instance, if you have a copper cable, you might have electromagnetic interference, so your data changes. So you have to make sure that if there is an error, you realize there is an error, you can detect it, you can correct it, you can resend something if something gets lost, which also means you have to be able to identify that something gets lost, a packet gets lost. And this happens a lot. So this is not a special case, but you can expect that for every bigger thing you send across the internet, an email, an image, video, and so on, things will get lost. And TCP/IP makes sure it gets sent again, it arrives. And finally, you have to somehow structure, because the internet is so large that it's not enough to just have every computer know every other computer, but basically you put in some kind of structure that you only have to know the computers in your own network, and you have to know how to get out of it, basically. And all of this together, the TCP/IP suite, how this works, is governed by open standards. So you don't have to be a member of an organization to read the standards, to follow them. You can be part of the IETF, which is a voluntary organization to govern these standards, to propose changes and so on. And they are published online in the so-called request for comments. So that's online documents, one of which I've linked here, that basically tell you what those standards are. And we can, before I stop this video, look into this one, and then we are up to date. So this is the RFC 1122, which basically tells what are the requirements for internet hosts for machines in the internet. And you see that it describes a little bit the architecture. That's more or less what I just talked about, but in much more detail. General things like error logging configurations, and then it goes into detail into the different protocols. And some of that is covered now in the remaining part of the lecture. A lot of it I skip because this is extremely detailed. So if you, for example, go into any of those things, you find really down to bit level information of how to send certain packets, how to make sure they arrive, how to correct errors. And so on. So that's it for now, and I hope you watch the rest of the lecture recording as well. Thank you.